Welcome to e-Padasala PG program for computer science students. Today we will be discussing about embedded system design process. In this module we will be looking at the various steps involved in embedded system design process, and we will discuss about the requirements, specification and architecture of system design, and at the end we will be discussing about hardware, software components which is required for the system design and how these two is getting integrated to form the design. So, when you are looking at an embedded system, the general general flow diagram, when you are looking at design process, there we will be looking at this requirements, specification, architecture, components and system integration. So, these are the very important things and it goes in a sequence, so that we will be in a position to design the methodology for making a particular product. So, this flow diagram shows that the design methodology. So, when you are looking up this particular design, there are two kinds of methodology we will be using it. One is top down approach, another one is bottom up approach. So, when you are looking at top down approach, we will be beginning with the most abstract description of the system and we will be concluding with the concrete details. But when you are looking at bottom up view, where we will be starting with the components to build a system and we will be ending up with what we will be going to do with that particular requirements. So, starting with the components and we are going from the bottom to up, so that it is easy for us to design it. So, when you are looking at the design methodologies, many of the people will prefer to go for bottom up design, because we do not have any perfect insight into how later stages of the design process will turn out. So, when you are looking at the major goals of the design to be considered when you are looking at your embedded system design is the manufacturing cost. As we know very well, when you are designing a particular product, the cost is the major fact. So, here we will be looking at the manufacturing cost. So, that is the thing which affects the overall cost also. So, the cost is the first goal we will be looking at for the design. The next is performance of the system. So, when I am looking at the performance, I will say that I will be saying that how fast it is, that means the overall speed and the deadlines. And the last one, which is not the least one, is the power consumption. How much power we will be expecting to deliver to that particular product. If we are making a product which consumes more power, then we know very well the side effect is, one is heat dissipation, another one is the power more and more power consumption, we need to give DC batteries more and more. So, that the users will not accept about high power consumption devices if it is of handheld devices and all those things. Anyway, when you are looking at a product, if the power requirement for the product is less, then people will accept that particular product very easily. So, we have to concentrate these major roles when you are going ahead with your design. So, the next is when we wanted to design a particular product, first we have to analyze the design each step to determine how we can meet the specifications. Then we have to refine them and again we have to look at that particular design to refine that, and we have to add minute details to our design. And we must verify this particular design to ensure that it should meet all the system goals, such as the cost, speed and all the precautionary things we made it, all the things it has to be supported. That means, if it has to withstand this much heat, in the sense it has to withstand, it should not burst within that particular heat. So, that kind of deadlines also has to be verified when you are looking at the system standard. So, we will be looking at the design process in detail, so that the design will be perfect. So, when you are looking at the requirements, so the first aspect of our design is your requirements. So, the requirement is nothing but the informal description from the customer. That means, if I am going to design a particular product, I should get the information what is needed by the customer, which is nothing but the requirements. But when you are looking at, they will be saying many things, but we will not be in a position to meet out all those things. So, we have to refine the requirements and we have to make that into a specification. So, when you are looking at a particular requirement, there I will be saying that the requirements is divided into two parts. One is functional requirements, another one is non-functional requirement. So what I am trying to say over here as functional requirement is, what will be the, if I am having a particular system, what are all the functions I need the system has to do, that will be the functional requirement. For example, if I am looking at a cell phone, I will say that I have to communicate, that means I have to talk to somebody else from outside, or I wanted to send a message to somebody from outside, or I need to receive a message from them, or I need to get a call from them. So that may be the functional requirement. But when I am looking at non-functional, what it says is it is not functional, but it is also very important, which is nothing but the speed, performance. The performance should be good, that means it tells you about the speed, the cost, the manufacturing and non-recurring engineering costs is combined to get how much is the cost it is acquiring, how much is the cost we are getting it from the customer. Then the physical size and the weight. Many times the physical size and weight plays a vital role when the embedded system is a part of a one big product, or if it is a handheld devices. Then the last one is your power consumption, that means how much is the battery I need to provide, so that what will be the battery life. So these are all the non-functional requirements when you are looking at designing a particular product. So let us look into a specific example, which is nothing but a GPS navigation system. Nowadays people are using GPS navigation system with the cars and other things. So there, if I am looking at this is a system I wanted to develop, then I need to provide a form to the customer. So that is nothing but a requirement form. So in this requirement form, all these left hand side things will be there. They need to fill up against this particular one. So the name, the customer has to fill up GPS navigational indicator or GPS moving map. Then purpose, the consumer grade moving map for driving usage. So the inputs, how many inputs they will be requiring. So power button as well as the two control buttons. And what should be the output? Output should be in the map form, so that we need a LCD display. Maybe they need 400 into 600 is a LCD display they needed. So when you are looking at the functions, they will be requiring that the GPS system which should have 5 receivers, so that the accuracies will be very good. 5 receiver GPS system, as well as 3 user selectable resolution, so that they can zoom it in a different scale. Always displays the current latitude and longitude, and it updates the screen with every 0.25 seconds upon movement. So these are the functions maybe the users are requiring, so that they have filled all these things against the function. So the performance updates is, the performance is nothing but the updation should be done with 0.25 seconds upon the movement. Each and every 0.25 seconds it should update the data of current latitude, longitude, and maybe the map also. Manufacturing cost, maybe they will expect 1500 rupees. The power, it is a rough estimate, maybe they will give it in a very less also. So power, it should require 100 milliwatt, and the physical size and weight may be 2 inches by 2 inches, and weight may be of very less size. So these are the requirement form which will be filled up by the customer or consumer. So this has to be taken as the requirement for that particular GPS navigation system. So the next is the specification. So what I am trying to say over here is the requirement gathers and refines the information given by the customer. They will give so many things. We have to get what is their requirement, and we have to refine it, and we have to provide the information. Now we will be moving towards the specification, where the specification serves as the contract between the customer and the system architects. That means the specification is a in-between person. From the requirement, I need to provide which and all possible. Based on that, I have to make a specification out of my requirement, which will be supplied to the system architects, so that they will build the particular system. So specification serves the contract between the customers and architects. So it is essential to create working systems with a minimum designer effort. So it must be specific as well as understandable and accurately reflects the customer's requirement. So basically we should think that ultimately we are designing a system which should meet out this customer's requirements, but whatever is possible, that will be made it into a specification. It has been given to the architect for designing work. So, when you are looking at the example, the same example GPS navigation system, when I am looking at what will be the specification given to with the requirement form, what will be the specification form given to the system architect is nothing but data retrieved from the GPS satellite constellation and map data, user interface, operations that must be performed to satisfy the customer requests and background actions. So, you just see that we need to get GPS satellite constellation, all your latitude longitude should be extracted, we should get it. The map data is taken from the spatial database from a database engine. User interface to provide what will be the destination and what will be the scale, we need to get all those things has to be provided, and the operation must be performed to satisfy the customer request, and some background actions also should be supported. So, when you are looking at the design, the specification describes only the functions of the system. So, the specification did not tell how it has been done, but it has given that what the system will do, what the customer expects the system to perform. So, now we need to find out how these functions will be done. That means how we will be getting these functions done at the system, that has been described by the architecture. That means the implementation of the system is described by the architecture. So, the architecture is a plan for the overall structure of the system. So, it will be used later to design the components. So, the architecture will be illustrated using the block diagrams in block diagrams. Usually, the system architects, by looking at the specification, they will make a architecture diagram which tells you that how we will be making the system to satisfy all your functions given by the specifications, and how we will be doing that also will be discussed in a detailed design of your architecture. So, you just see that the same example GPS navigation system, it has been given with the architecture diagram. So, in the architecture diagram, the satellite constellation is there. From there, the GPS receiver gets the latitude and longitude of the current position of the person, maybe it is a vehicle, and there is a search engine. So, if he stands at a particular place, naturally he will ask some destination place and how to go to that particular place. So, he will be making a query through this particular search engine. So, the search engine takes a spatial database, that is nothing but a map data, and it comes over here, and it takes, this is the source data which received from the GPS receiver. Now, he says what is the destination. This from the map it searches and it finds what is the route with it will show you the route. So, now that particular route is given over here, this rendering is done over here, user interface is provided, so that what will be the zoom size you wanted to see, that you will be providing it. So, now with the search engine and with the user interface, we will be looking at the map, and that particular map is displayed in the LCD. So, now you just see that the route map is displayed with your LCD. So, this is actually architecture diagram of a GPS navigational system, where it tells you about receiving the data and it searches with the destination, and with the user interface it creates the map data, and that particular route map is displayed with your LCD. So, it gives you all the functions which we have described as a specification is implemented through this particular architecture design. Now, you just see that this particular architecture gives you initial architecture. So, detailed architecture, we have to see each and every block has to be explained, I mean how it will be implemented in a detailed way. But when you are looking at, anyway, that is a different part. Now, when you are looking at this system block diagram, we have two things has to be considered. In this block diagram, there are two parts is there. One is hardware part, another one is software part. So, when you are looking at the architecture diagram, in the system architecture diagram, only the hardware block diagram is taken separately and it has been displayed over here. You just see that your CPU, your GPS receiver and your IO, these are all hardwares. So, that GPS receiver receives the coordinate given to your CPU, your IO devices is used for your user interface. Now, it is queried and it will be, the frame buffer is there, and from the memory only, from memory is a hardware. So, you will be taking your spatial database from there based on the query, it gets extracted, frame buffer is there, that particular frame is displayed on your LCD. Now, you just see that it gives you a clear picture about what are all the hardware we will be using for this particular product to be developed. Now, when you are looking at this hardware block diagram, there is one central CPU surrounded by the memory and I/O devices, and we have chosen two memories. One is the frame buffer, another one is the data memory, which will hold the spatial database. And this is when you are discussing about a hardware, definitely we have to see at there will be a software block diagram also. So, when you are looking at the software block diagram, we will be having something like position is taken by the GPS receiver. So, this coordinates, positional coordinate, latitude, longitude, positional coordinates, which will be given to the user interface. Now, the user interface software is sending a query to database, so that the database is searched and we will be getting what will be the data we wanted to have it. The user interface and the output has to be maintained with a certain time. The input as well as output has to be maintained with some time synchronization that has been controlled by this timer module. So, that you just see that we need to have a software which should take the latitude, longitude, position, and it should make a query and it will be given a destination, the route map, which has to be displayed. Program which helps to display that particular data is done over here, so that I will be getting the output which will be displayed at my LCD. So, these are the software architecture we need to look at when you are designing this particular product. So, the software block diagram fairly follows the system block diagram. So, we have added a timer to control when we read the buttons on the user interface and render the data onto the screen. So, to have a perfect synchronization between these two things, because of that the timer is also included over there. So, to have a truly complete architectural description, we require more details, such as where units in the software block diagram will be executed hardware block diagram, when the operations will be performed in time. So, all the software we will be writing it which has to be burnt in our means what are the softwares we have written for doing this particular process has to be embedded into the hardware, so that we will be getting the product. So, the architectural descriptions must be designed to satisfy both functional as well as non-functional requirements. And not only the required functions to be present, we must meet, we would have satisfied both functional and non-functional requirement, but we need to maintain what should be the maximum cost we can go for producing this particular to developing this particular product, as well as what should be the speed we have to maintain, and how much is the power we can give, how much less power we can provide to this particular product. These are all the non-functional constraints that also we have to maintain when you are looking at this product design. So, when you are looking at the architecture design, the hardware software architects is not of the same kind of persons. The hardware should be done by one group of persons and the software should be done by another group of persons. Now, these two should be work together, so that we will be getting the system to work properly. So, how do we know that our hardware and software architects in fact meet constraints on speed, cost and so on? That is the next question when you are looking at an architecture design. So, estimate the properties of the components of the block diagrams. First, we have to see that what will be the properties of the components in the block diagram. That means the searching and rendering functions in the moving map system. So, that we have to verify what will be the property of that. Then, accurate estimation derives in part of with experience, in the form of experience, as well as experience with the design as well as implementation. So, the person who has a very good experience can say that how much time it will take to do all these works. So, sound estimates of this non-functional constraints, and we have to look at whether we will meet out this non-functional constraints or not. That has to be validated by different experts in that particular fields. Since the decisions based on bad data will show up during the final phase of the design. So, the different test cases has to be taken, good data or bad data, what will be the data we have to take, and we have to test it with our model, so that we have to ensure that our product is meeting the what will be the deadlines we have fixed, that will be met out by our product. And the the architectural description tells us what components we need. See, when we are looking at the speed has to be improved, then we need to go for a very good hardware. That means the hardware of a high speed. If I am looking at high speed, then maybe the cost is also high. So, there is a compromise we have to make it with the speed as well as the cost, so that we have to come to a conclusion that what kind of processor we have to use for doing this particular product. So, it tells you that what components we needed, that is also very important. The component design effort builds those components in conformation to the architecture as well as the specification. So, the components will in general include both hardware and software models. So, the when you are telling about the components of a system, it tells you both hardware as well as software. So, some of the components we can buy it ready made. For example, the component is your CPU, maybe the processor or memory chips. And when you are in the moving map, we will say that the GPS receiver is a pre-designed standard hardware component. So, GPS receiver we need not build because it is available, we will buy it directly. And the topographic software, that means the spatial database, which is a standard software like your Google Maps. So, that kind of Google Map and that kind of spatial database software is a standard software model which is available, which can make use, we can make use of that particular one, so that we will use standard routines to access that particular database also. And the other components, when you wanted to make it, it has to be attached, or you will be looking at your LCD panel, you can buy it, but the interfacing and all those things we have to make a different PCB board, that means printed circuit board or the components which needs to be designed. So, lot of custom program is required while we are integrating all the hardwares together. So, when creating these embedded software models, ensure the system runs properly in real time and that it does not take up more memory space than it is allowed. So, the power consumption of the moving map software example is particularly very important. See, when I am looking at the GPS navigation system, on the real time, if I am standing in a one particular position and I am asking a destination, then the current latitude, and it will look up what is the destination latitude, and it queries with the spatial database, it extracts the design. When it shows it, if it takes more time, maybe our vehicle would have moved to a different place. From there, maybe that route may not be available, we would have taken a different route. So, because of that, on the real time, when you wanted to get the detail, how fast you can get the data, that is very important. And the memory space, when you are working with real time, then it should not take more memory space. If it takes more memory space, then we need to provide more memory space to the system, as well as it may hang up. So, those things has to be considered when you are looking up your real time, any of the applications we have implemented through embedded systems. Then the power consumption of the moving map software example is particularly very important. We are using a navigation system where if it eats more power and it drains up in between, then we will not be using that particular device while we are driving on the car. Maybe we need some map, by the time the power may not be available, so that we will not be in a position to use this particular device. So, that is a unwanted situation. So, because of that, we will say that the power consumption of this particular device should be very less, so that we can make use of the device for our entire drive maybe. So, you may need to be very careful about how you read and write memory to minimize the power. So, for example, the memory transaction must be carefully planned to avoid reading the same data several times. So, the power will be consumed when the processor is working more and more. If I am reducing it, the working with your processor is reduced, then the power consumption is less. So, most of the time the power processor works is far, it has to read something from the memory. So, each and every time many times it reads the same data from a particular location, then we will avoid doing that kind of job. Only one time if I am reading it, I will keep it somewhere here, so that again and again I need not go to the memory positions and read it. So, that way only, that means they are optimizing the memory transaction. So, because of that, the work of the processor is reduced, so that the power consumption by the processor is also reduced. Since the memory access is the major source of power consumption, because of that we will drain the power very easily. We can optimize this situation, or we can avoid this kind of situation. So, while we are writing a code, or when you are making the system to work, we have to identify what are all the process which takes more power, we will try to avoid, so that we will minimize the power consumption. So, system integration. So, after the components are built, they are integrated. So, as we know that your hardware as well as software is made separately. After I mean the people who are working with the hardware will make it perfectly, they have worked out well, and the software is done perfectly and they have worked out well. But when we are integrating these two things, that means whatever be the software they have written and they made it work with simulator. So, when the simulator, when you are working out, it never reads out the real time problems. So, because of that, the software may work perfectly well with the simulator, I mean while they are developing as a software, but when they are putting the same software on the hardware, it may not work properly. So, because of that we will say that you will be in a position to understand that the integration is very important. The hardware, whatever be the software we have written over here, has to be embedded onto the hardware and it should work properly. So, the bugs when you are finding it while integrating these two things has to be debugged properly, so that we will be getting a perfect model. But remember that when you are correcting the bugs, we may not be getting like a system kind of setup. See, when you are writing a code on a machine or a computer, we can debug very easily by looking at the monitor as well as with the keyboard. We can edit it again and again and we will see the results, so that we can correct the problems very easily. But when you are looking at when the software is embedded with your hardware, there we do not have a keyboard or a maybe the panel to CRT or a display device to see what will be the results each and every time. So, because of that, the inputting and outputting is not that much as comfort as system programming, so that the debugging with respect to the embedded systems are really very tough. So, the good planning can help us to find the bugs very quickly, and by debugging few models at a time, simple bugs can be uncovered. So, by fixing simple bugs yearly, more complex or the other bugs can be uncovered. So, you just we need to know that when you are integrating these two things, the bugs has to be quickly resolved, so that we will be integrating these two things properly. So, the integration is very difficult because it is usually uncovers the problem. The debugging facilities for embedded systems are usually much more limited than the desktop systems. So, careful attention to inserting appropriate debugging facilities during the design can help the easy access to the system integration problems. So, in this lecture, we have covered embedded system design process. In that process, the basic first thing is your requirement that has to be collected from the consumer, and the specification, which will be a interface between your consumer as well as the system architect, that we have discussed detail. Then with the specification, how we are making the architecture design to make a system, that we have discussed. Then how the hardware and software components are handled while we are making a system design, and how after making the hardware and software components, how it is getting integrated, that also we discussed in this particular. What will be the problems we will face, how to solve those problems, those things we have covered in this particular module. So, the reference is taken from Wolf, Computers as Components, Principles of Embedded Computing System Design by Wolf. It is 2nd edition. Thank you.